Hi students, in this lecture let us discuss about methods of generating time-based waveforms. So depending upon the methods of generating time-based waveforms, we are having n number of methods. So in that one, the first method is exponential charging and second method is constant current charging. Third method is Miller's circuit. Fourth method is bootstrap circuit. Fifth method is compensating method, and sixth method is an inductor circuit. Okay, these are the few methods. So in these methods of generating time-based waveforms, which one is good method means Miller's circuit method is good method for the designing of time-based generator waveforms. And next thing is, first of all we will consider the exponential charging method. So what is the meaning of exponential charging method means, in this method a capacitor is charged from the supply voltage through the resistor at the voltage which is small compared with the supply voltage. So in this method, to design the exponential sweep circuit, so we have to consider the capacitor and resistor, and next we have to give the some type of the supply voltage. So that circuit is known as exponential sweep circuit. So exponential sweep circuit is in this form. So this is the exponential sweep circuit. In the exponential sweep circuit, we have taken the capacitor C, resistor R and supply voltage V. And next we have constructed one type of the switch S also, switch S. So this is the simple design of your exponential sweep circuit. After designing of your exponential sweep circuit, we have mentioned this circuit as figure A. And next, how this output waveform will be generated, let us discuss. So in figure A, we have shown the exponential sweep circuit. Means initially the switch S is closed. Initially the switch S is closed and S is open at time t is equal to 0. Means at the initial time level the switch S will be open. It may be 0.1 second or 1 second or 1 minute. Whenever the time t is greater than 0.1 second, then the capacitor start charging towards the supply voltage V with the time constant t is equal to RC. So when the capacitor will be charged here means when t is greater than 0. So then only the capacitor will be charged, then this type of the waveform will be generated in the output. So why we have to consider the capacitor and resistor, why we cannot consider the inductor? That is also very important point. So why we are not taking the inductor means, inductor will be considered in some of the application part, but the majority of the in the majority of the applications, which type of the circuit element we are taking means capacitor. So that is the main thing. Now if you replace this capacitor with the help of the inductor, then this exponential sweep circuit will be changed into a inductor circuit, will be changed into a inductor. So that is only the difference. And what are the few points regarding to this one means, few points means, whenever this output waveform is generated, how this output waveform is generated means, whenever this capacitor will be charged, this supply voltage will be taken. Means whenever this supply voltage, how this supply voltage will be generated means, when t is equal to 0.1 second, then the switch S is closed. Whenever the switch S is closed, then the supply voltage will be start from the resistor to the capacitor. That is whole circuit will be supply with the voltage V. Whenever this voltage V is supplied, then this capacitor will be charged. Whenever this capacitor will be charged, then we will get the waveform in the exponential view. So exponential. So we have written that term in the voltage, that is Vs, that is sweep voltage. Okay, sweep voltage, and this is Ts, that is sweep time, and it is exponentially increasing at a one time period, that is T is equal to Rc, that is T is equal to Rc, that is maximum voltage. At the maximum voltage, the exponential increasing sweep circuit will be stopped. Okay, and how it is calculated means by one type of the standard formula which is used in the exponential sweep circuit, that is Vs is equal to V naught, that is Vs is equal to V naught, that is output voltage, that is V into 1 minus exponential minus T by Rc. Here minus T means sweep time, and here V means you can take the maximum voltage. Okay, maximum voltage versus sweep time. And next thing is, already we have known that this is the standard formula. And next point is, after an initial time Ts, when the sweep amplitude attains the value of Vs normally, then the switch S is closed. Means at the certain level it is increasing. Then what happened, this function for the switch, this switch S will be closed. Switch S will be closed. Then what happened when the switch S is closed? The increasing sweep circuit waveform will be stopped. Means here only it will be, again it will not be increase linearly. So this is how the output waveform is generated by taking this exponential sweep circuit. And after calculating the output waveform, again we have to calculate the three types of the errors. So what are those three types of the errors means? One is slope error, and next one is transmission error, and next one is displacement error. So the same in the previous lecture, three types of the errors will be generated in the time based circuit waveforms. Okay, why the errors will be occur in the time based waveform means, whenever the output waveform is generated, then some type of the distortion or some type of the noise will be generated. That noise or the distortion is referred as here error. So depending upon the exponentially increasing or decreasing, so depending upon that one only we are having three types of the errors. So these errors are very important in this terms, because if these errors will be occur, then what happen, if we not calculate any type of the errors, if we not remove any type of the distortion, then simply the design of your circuit waveform will be loses its characteristics level. Characteristics level means the performance of your circuit or the stability of your sweep circuit will be loses. And next thing is, we had to derive the relationship between ES, that is slope error, ED, that is displacement error, and next one ET, that is transmission error. For the slope error, in the previous lecture you have to remember the formula, that is this is the slope error formula. Here V naught we have taken. So what is V naught means? V naught is equal to V into 1 minus exponential minus T by RC. So in the place of V naught you have to substitute that value. Again you have to calculate the value of slope error. So if you calculate the value of slope error, then we will get ES is equal to TS by RC. Okay, and next thing is displacement error. So what is the formula for the displacement error? It is given by ED is equal to Vs minus Vs dash maximum by Vs. Here Vs means output voltage, Vs dash means the maximum voltage which you are getting here. So here we are taking here. So here the value of Vs, that is Vs 1 minus T by RC, but here T is equal to minus Ts by 2. Why means here it is linearly increasing, and again after the time period 2, that is half time period, again it is linear. So we are consider the slope time into two values, that is one half slope time and full slope time. So at t we are considering here t is equal to ts by 2. So in the place of t we are substituting ts by 2. So after completing that one, we are substituting the equations and we are calculating the value of displacement error. So the value of displacement error, again you have to substitute step by step and you have to derive the equation, that is at last we will get ed is equal to ts by 8 rc. Okay, ts by 8 rc. So ts by rc. And next error is transmission error, that is et. So this is the waveform which we have generated here. So again we have to write down the formula. Transmission error is equal to vs dash minus vs by vs dash, that is when t is equal to ts. Again you have to substitute the value. Again we will get et is equal to ts by 2 rc. So after calculating these three errors, you have to calculate the relationship between these three errors. So again the relationship between these three errors, it is given by, that is es is equal to ts by rc, ed is equal to ts by 8 rc, again et is equal to ts by 2 rc. So we are taking, so first of all we will consider the slope error and the displacement error. So slope error divided by displacement error, how much you are getting? 8. Again slope error is equal to 8 ed. Again after completing this one, again we are calculating slope error divided by transmission error. So we are getting es by et is equal to 2. Okay, this is completed. So again we are substituting in the values of what is es in the above equation. So es by 2 is equal to 2 et. es by 2 is equal to 2 et. So after completing this one, total what is the relationship we are getting means es is equal to 8 ed is equal to 2 et. Therefore ed is equal to es by 8 is equal to et by 4. Okay, this is the how you want to calculate the relationship between the transmission error, slope error and the displacement error. Okay, we have taken the n number of methods, yes or no? The same procedure will be applicable for all those methods. So whenever you are taking the exponential sweep circuit method or the Miller's method or the bootstrap method or the inductor circuit method or any type of the composition method, you have to calculate only two parameters. What is those two parameters means? First of all you have to calculate the output waveform which you have generated from the design of that circuit, and second point is you have to calculate the relationship between these three errors. You have to calculate the relationship between these three errors, then only you can know that how that output waveform is generated and what is the relationship between these three errors. Okay, thank you students.